Hello and welcome to my video on my project about modeling worldwide suicide data. I worked on this project with one other student as part of the final project of a statistical learning class. And I hope you learned something new today. So we found our data set off of Kaggle from a user who combined three different data sets together. These three data sets came from the World Health Organization and all revolve around suicide data. So you can see that for a given country and year, the population is broken into many groups. For instance, males aged 15 to 24, and then gives their suicide number given the entire population and the average GDP and capita per year and per capita. Then there's also an HDI index, which is used by the World Health Organization as a happiness index for that country. So we can see that by filtering the data set, we can look specifically at suicides per given country, as we can see from the US and the UK, or we can even filter it by age, and we can see the overall suicides based on different age ranges. We also did some analytics beforehand to see if there's any correlation problems we should be on the lookout for. The strongest correlation we can see here is a 0.7 for GDP per year and population. Not so high that it should cause us any problems. We also went ahead and looked at the VIF scores to make sure that there wasn't any multi-collinearity problems to be aware of, and since everything's below 5, we're good on that case too. So my question was question 1, so it will be the only one I'll be talking about today, which was how accurately can demographic information like sex, age, and generation be used to predict the number of suicides per 100K of that population? Some sub-questions I wanted to look at while I answer that is, how does this accuracy change over the years? And does a single decision tree, bagged model, or random forest technique perform the best at this task? So this is an overall view of my methodology. So for each one of these years from 1990 to 2014, for each year I'm going to create a training set and a test set. The test set is made up of 5 countries that were removed from the training set. So using that training set, I'm going to create a single decision tree, a bagged model, and a random forest. Then using the test set, I'm going to find the model mean squared error and the prediction mean squared error for each one of these models for each year. And then I'm going to find which model overall performed the best. So this is just a little bit of the code on how I'm creating my single tree, and how I'm pruning it to get the best tree, and then how I'm actually using it to get the mean squared error from the model, and from the prediction using the test set. So here's an example of what that decision tree looks like. We see that if you look at the very top, is it a sex female or male? If it's male, it goes to the left. If it's female, it goes to the right. Then we look at the age. And as we get lower into the tree, we can see that factors like the happiness index and the GDP per capita start playing a bigger role into getting a more specific number. So this graph shows how the bag model is performing. And I included a little bit of code to see how that bag model was made. And we can see that the error decreases after about 500-ish trees, and then kind of tapers off in the error around 70. And that's not 70%, that's 70 given the context of the data. So here's how I created the bag models and the random forest, just a little bit more glimpse of the code, what's happening behind the scenes here, and how I'm getting these numbers. So then this graph compares the bag model to the random forest and shows the importance of each variable. So we can see that sex, age, and HDI, which is that happiness index, were the 3 variables that are the most important in both models. And then this graph compares the errors for all 3. So we can see that the leave one out cross-validation error for the single decision tree is shown in blue, which is the highest. And then our out of bound error for the random forest is in black, and the OOB error for the bagged model is in red. And we can see that the bagging model seems to be performing the best here. Then what I did was I went ahead and collected all of these error rates for all three models over all of these given years, and found that the lowest model mean square error was the bagging model, but the lowest prediction mean square error, which is the one we actually care about more, is the Random Forrest. And we care about this because this is the error when actually predicting on new data, which is how we would use this model if we actually wanted to predict the suicides for a given population. So overall, we can see that it had a 71 mean square error. Again, that's not 71%. That's it is generally off by 71, which is not terrible in this case in the context of the data. And that's the end of the presentation, on my part of this presentation at least. Hopefully you were able to learn something new about how statistics can be used to predict important things like, for instance, a common problem of suicide. And hopefully you learned something new. If you want to see more of the code and what's happening behind the scenes, please check out my GitHub linked on the YouTube account, and thank you so much for listening.